Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. Hello and welcome, automotive world. This is the Automotive Diagnostic Podcast. My name is Sean Tipping. I will be your host today. Thank you so much for listening. Today, I'm very excited. We have a guest on the show, Mario Rojas. Mario is a diagnostic technician that works in Florida. He has a YouTube channel, Super Mario Diagnostics. Make sure to check that out on YouTube. He has a number of diagnostic and educational videos. He is going to help me today in our third part of our three-part series involving engine mechanical testing using scopes. Today we're going to talk about pulse sensors and how they're used during these mechanical tests of an engine to determine the mechanical state of an engine. It's really interesting how these pulse sensors work, and there's a lot of variables that go into it. And so I thought another perspective would be very helpful. We're also going to talk to Mario about what he's got going on with his YouTube channel and a few other things. So I'm really excited. Let's get into it, and make sure to check the show notes because I'm going to have a ton of different links for some of the things that we referenced during this interview. All right, Mario. Hey, thank you for joining me on the show today. I really appreciate it. How are you doing today?
Pretty good, man. I'm honored to be here. I'm glad you have me as a guest. It's pretty awesome.
Yeah, definitely happy to have you here, helping me out on this episode. So you are down in Florida. I just want to talk a little bit about you for the listeners, get a feel for who you are and what you do. You're down in Florida, and you are working at Autobahn Performance. Is that correct?
That is correct. Yeah, I'm actually wearing my shirt.
Oh, yes, so, perfect. So you just started there recently?
Yeah, I'd say about 3 months now.
And is that mainly European focused shop, or what's their thing?
Yeah, for the most part, it is very heavy on European, but they take just about anything. But the majority is definitely European. I've only touched like a handful of domestics and imports.
How was that transition for you? I know you were doing a lot of, independent stuff where you see a little bit of everything. I know for me, when I was doing independent work, you'd get a European vehicle every once in a while. You'd see a few Volkswagens here and there, and then every once in a while you get a BMW or Mercedes, and it was always a challenge, a learning curve when you got one of those in your bay. How's that transition been for you?
That's where we share similar experience because I went through a similar transition in an independent shop with very heavy domestics and Japanese vehicles, and only maybe once or two European a week. And the good thing is that when they did come, they were pretty heavy jobs. So I got pretty good experience with them, but nowhere near as much as I'm getting now. And the learning curve is pretty steep for those who are fresh at it. But once you start to see those very common problems, I'm not going to say, that it's a good thing. It has its pros and cons, but once you start to see these little details with these European cars, it definitely becomes a lot easier for you.
Okay. I mean, yeah, at the end of the day, it's all nuts and bolts, but I think anybody that's done any of this stuff you can realize that there's definitely just a different thought process that goes into the engineering, the construction, and the diagnostics of those vehicles. So it's really nice, though, to be able to be exposed to that on a consistent basis. I mean, you got to be picking up all kinds of things. Seen anything recently, really interesting on the European side that you like to share?
I've gotten a lot of challenges lately. Where do I start? Because almost every car has been quite a challenge. And surprisingly, this shop gets a lot of immobilizer issues. I just
Okay.
had a Jaguar that I have the Altel IM608, which is, you know, a great starter key scan tool, I guess you could call it. But I was ill-equipped to handle that vehicle. And this vehicle is a KVM module, it's a keyless vehicle module. And you have to remove certain parts of that module and then put a programmer in it, unlock it, add the key, and then reinstall everything, put it back into the vehicle. So that's where I really learned how ill-equipped I was when I was confronted with this vehicle, and had to buy some programmers. In the end of the day, once we were at the home stretch, at that final piece of the final repair, which was to program a virginized module, the client decided to bail out on us. And he went on his way. He actually gave us a different Jaguar to deal with, so it worked out.
Yeah, that's got to be interesting. It's fun though, you know, if you're into that sort of thing. That's learn all the new stuff. That's awesome. I also want to talk a little bit about your YouTube channel. You have Super Mario Diagnostics. You got a ton of videos on there. Great stuff. Just, you know, vehicle diagnostics. I think there's a few repair videos as well. You tell us a little bit about that, and then I'm also interested to know, you know, what was your inspiration or the reason why you decided to create and continue creating content, because you know, it's a lot of work. You know, all the production that goes into it. It's not as simple as just fixing or diagnosing a car to make a good video. There's a lot of work behind it. So I'm just curious. I always like to know what people's inspiration is to do something like that.
Well, it started by using YouTube as a resource, and you know, YouTube, you can find anything. There's no excuse to find any resource, and YouTube is a big platform. So it was very heavy in my learning. I referred to YouTube for a lot of things, but usually it was mainly to learn at home, not while I'm on the job. It was mainly to learn theory and fundamentals and electrical diagnostic strategies and whatnot. And well, it goes without saying, it probably hundreds of thousands of technicians can say the same, that they've seen Scanner Danner, and that was a huge inspiration for them to continue on forward. I was actually on the fence about whether I wanted to stay in the industry or not at a certain point, up until I saw the use of a scope. That's really what kept me in. Once I saw that scope showing those signals, I was blown away, and I knew that this was what I wanted to do. My YouTube channel, it started really with my brother, to be honest with you. He worked with me for a couple of months in a flat rate shop, and he knew I was into these YouTube videos, and he said to me one day, you know, I'm learning from you all the time. Why don't you just make these YouTube videos for when I'm at home? You know, I could just watch them later.
Okay.
He was a sponge. He wanted to learn everything. Even like when we were out at dinner or something, or we could talk about his cars. So he said, just make a YouTube channel and I'll be able to watch it on my own time. And at first, you know, casually I laughed it off. I'm like, I'm not Scanner Danner. Why don't you just watch him? And he was like, oh, just think about it. You know, it's just an idea. And eventually one thing led to another. I bought a camera and a GoPro and started filming, and started seeing how it wasn't as easy as it looked. Once I started filming, I realized that technicians who film themselves, that's a whole other league, because you're in two places at one time. You're focusing on what you're saying, you're trying to be cohesive, you're trying to be concise, but at the same time, you're trying to do your diagnostics. So it's not that easy. And on top of that, the editing and the technical difficulty. Sometimes your laptop might not keep up with the the movie editing software or whatnot, things like that.
Yeah, I mean, learning all kinds of different things that as a auto technician, you don't ever deal with any of that stuff, like, yeah, editing a video or dealing with an audio track or all this stuff, which, yeah, you can figure out, but it's a whole nother ballpark of stuff to take on. So, people that just watch the videos, I hope they appreciate the work that anybody puts into them. I tried a couple and it went terribly. So I decided to go with a podcast because they don't have to see what I'm doing. I can just talk, right?
And it's a great idea. I love what you're doing here. It's very entertaining and it's healthy learning. And it's extremely convenient, even more so than YouTube, because I don't have to keep my eyes on the screen at all times. I can listen, and if you can explain yourself in a way that you don't need video, that's pretty amazing in itself.
Yeah, not always the easiest thing with our field of video. It really gets a lot more across, but it was the same thing. That's why I decided to start it was, I would play the YouTube videos on my phone and have my earbuds in or whatever, and I'd be working, because I was just always doing something, and I'd pull out the phone where I'm like, what the heck is he talking about? I got to see the video for this part. But yeah, I wanted a podcast because I listen to podcasts for other stuff that's not really automotive related, but I'm like, I want somebody to talk about this on a podcast. And there wasn't that specific, there's other automotive podcasts, but there wasn't that specific thing I was looking for. So, well, I guess I'll give it a shot myself and see how this goes.
And it worked out just fine.
Yeah, we're off and rolling. Anything else going on with you that you've got cooking that you'd like to share?
Well, really, all I'm really involved in is the YouTube channel and the Facebook groups. All I try to do is to have people ask questions, in these groups. It's just to share. This Facebook group is called Automotive Insight Network. I did make another group, but it's totally unrelated in a sense. But I'm not really cooking much more than that. I don't build stuff. I don't, monetize on other things. I fix cars and I share how I fix them.
Awesome. Hey, that's plenty. Yeah, Automotive Insight Network. That's the name of it, correct?
Correct.
Okay. Yeah, that's a great Facebook group. If you haven't checked that out, anybody that's listening, make sure to do that. A lot of really smart technicians in there, and everybody is very friendly and helpful, which can't be said of a lot of Facebook. So check that out if you haven't already. Great stuff there. Well, let's get into the main reason that I wanted to bring you on with me on the show today. I'm doing a little mini 3-part series here on engine mechanical testing using scopes. And I went through relative compression. I went through in-cylinder pressure testing with a transducer. And the third part of this is going to involve pulse sensor testing for, again, mechanical engine components. I really honestly was thinking about it and my own personal knowledge, and I was like, I think I need a little bit of help here on the topic. I have them, I use them. We've actually talked to Cody and Brandon that sell the sensors. We talked a little bit about their function, but to be totally honest, I'm still learning on these things. Every time I plug one of them in, I'm looking at it like, well, is that necessarily the problem? Is that it was what I'm seeing, what I think I'm seeing, that sort of thing. And I understand the idea, but I thought having somebody else here to cover the function, the use of these sensors would be really helpful. And you've got some great material, some videos out there demonstrating their use. So that being said, let's start off just recapping, what a pulse sensor is, what it's actually doing, and for this topic, how it's different than a pressure transducer, because that was the tool that we talked about in the last episode. What's the difference between a pulse sensor and a pulse or a pressure transducer?
So a pulse sensor is a piezoelectric sensor enclosed. It's housed within a chamber. It's built It's custom built according to however you want to make it. You can change the voltage scale, the way it reacts, and its sensitivity. And what it does is react to change, and it interprets that through an AC-like voltage. I guess you could call it an AC-coupled voltage output, and it will tell you how fast pressure is changing and in which direction. Is it negative pressure? Is it positive pressure? So that differs in a pressure transducer in the sense that the pulse sensor only tells you the differences between pressures, much like a relative compression test. A relative compression test will give you a comparison between all cylinders, and the pressure transducer is more like the compression test. It's giving you that one specific cylinder without necessarily comparing another one, unless you were to put that transducer into another cylinder and compare it much like you would a mechanical gauge. And the pressure transducer is an absolute sensor, so it'll give you the exact pressure that you're seeing in the form of PSI instead of just an output voltage like the piezo sensor would.
If I had a static pressure, let's just say I had a static 10 PSI in whatever I'm measuring, it would show that as 10 PSI with a pressure transducer. It would jump up on the scope and it would show 10 PSI. What would that show if I was using a pulse sensor?
Well, if it was a static pressure, it wouldn't show anything. It would stay in the center line at 0 volts. Unless you were to induce a change on that pressure, it wouldn't move.
So that's really the key there with the pulse sensors, is the change in pressure that it's gonna show you on that scope.
That is correct, and it's got its own ways. You could do the same thing with a map sensor. You can analyze a waveform with a map sensor, an absolute pressure sensor, but it won't give you the same amount of sensitivity, the amount of resolution, and shameless plug, but I did show a video showing the difference between a pressure transducer and a piezoelectric sensor, and the difference is pretty big. And some people might not know this, but the WPS, it has a zoom function that kind of mimics a piezoelectric sensor. It's not as clean as a piezo sensor, but it will get the job done in most cases.
Yeah, I've messed around a little bit with mine, putting it down into the I don't know if you call it the higher range 3, and using the zoom function and trying that in the intake. But yeah, these pulse sensors, they're very, very sensitive to changes in pressure or even vibrations. And so you really get that detail that you're looking for. So if we're using these to test the mechanical state of an engine, where are we plugging these things into? Where are we connecting them to the engine? I know there's more than just one option, but what do you do with these sensors when you're going to go into a test?
It's all about preference in the end, but my preference would be to start off with the intake pulse, usually because it gives me the most amount of information with just one capture, and I make it a habit. People joke around, like PJ from Voltage Drop Diagnostics, he laughs when I say this, but I say it all the time. You have to isolate the intake from the crankcase in order to get an accurate waveform, because those two separate systems are connected through the PCV system. And if they're connected at the time that you're capturing an intake pulse waveform, you may have the effects of the crankcase pressures being shown into the intake pulse waveform. So I do suggest either plugging or clamping the PCV breather hose. But my first step is usually an intake pulse, just to start.
And that's huge. Yeah, just that little piece of information. I mean, you'd have to get your butt kicked on something, make a bad call in order to know that. For me, that's the only way I really would have thought that it's that sensitive, those things are connected through a
Oh,
PCB system, and that it's picking up pressure changes from the crankcase and the intake. And that's why, yeah, training on these things is huge, getting that information. So awesome piece of information. I didn't mean to interrupt you. So we can connect them to the intake and we can see intake pulsations. Where else can we utilize these sensors?
so the next step would be, if my intake pulse looks pretty good, you have a relative compression test that you can see an obvious low contributing cylinder, but your intake pulse looks fine, or it reacts to crank speed upon that low compression cylinder, then you may want to move on, right? So my take is to take that PCB breather and either unclamp it or plug it back in and watch for a change in the waveform. And if you see a change in the waveform, more than likely you're going to want to look at the crankcase for either cylinder wash, or lower end sealing issues.
Okay. So we're using some of these tests in conjunction with each other.
Correct.
Yeah. And that was part of my challenges with, I know, doing the intake pulses. When I'd look at them, I'd see one that's different than the rest. Okay. So you're hooked up to the intake, you crank this thing over, and maybe I should even pause there and ask, are we doing these tests cranking or running?
That is a very good point to make, because when doing pulse waveforms, anything that can affect cylinder contribution, anything that can cause a misfire running, that waveform will be affected and it'll be skewed. So cranking would be my preference. I would always suggest to do a test cranking before moving on to running waveforms.
Okay. Good to know. And that's again something that you kind of have to either go to the training, or you're just going to have to struggle through it to figure that sort of thing out. And I've definitely been on the struggle side of it. So anyway, so I'll look at the waveform and I'll see one's a little different than the rest. You see an intake pull from each cylinder, and one looks a little different on there. Now a couple challenges. One, where does this different intake pulse belong to? Whose cylinder is that? Which intake stroke is that? And then why is it that way? And some of the stuff that I've read and seen is, like, you've had videos on change in engine speed, speeding up and slowing down can affect how those pulls look. And maybe it's not necessarily on the bad cylinder. Am I making any sense there?
Absolutely. It's one of the things that catches the most. It caught me plenty of times, and I don't want to make it seem as if I didn't go through the rough, wild rides myself. Even though I've been trained by Brandon Steckler, it doesn't mean that I didn't have to go through those things. And that's how, the reason why I share these things so much is because I've gone through it. And I just, if I could spare somebody from going through these same, goose chases, I will do so. So what you're talking about is crank speed and how it's affected by a low compression cylinder. And what happens with a low compression cylinder, if you look at an RC test, a relative compression test, you can see that low contributing cylinder and the crank speeds up past that low contributing cylinder. But then when it's confronted with a good cylinder right after that low compression cylinder, as Brandon would say, it's like hitting a brick wall. It slows down. It decelerates so much that much more current is required from the starter to overcome that good cylinder. So how does that affect our intake pulse, or any pulse? The faster the crank speed, the stronger the pull. If it's an exhaust pulse, it would cause a quicker pulse, a higher pulse. So if you are looking at an RC test with one low contributing cylinder, you're going to have, if there's nothing wrong with the intake valve, on an intake pulse, you're going to see a deeper pull as the crank speeds up past that low contributing cylinder. But once it slows down, when confronted with that good cylinder, you will see that intake pulse rise as if it was a pressure pulse. But it's not to be confused with a pressure pulse. It's just the effect that a decelerating crank has on an intake pulse waveform.
That makes sense. And the way that I've tried to utilize that is sometimes that hurts my brain to try to figure out, okay, that belongs to that cylinder. I focus on using it in conjunction with what I already have for information. So the relative compression test, and that's a pretty accurate one. You know, this cylinder is low on compression. And then do I have a misfire code that goes along? And then I can really zero in on a cylinder, but it really will point me towards, okay, I definitely have a mechanical issue here. This engine is not breathing properly on that cylinder. But yeah, sometimes tough to pick it out just from the intake waveform, at least from my perspective.
And you make a good point there, which brings me to another point, which is never forget the suspect cylinder. Usually these tests begin with an RC test, a relative compression test. Once you have that suspect cylinder picked out, do not deviate, would be my biggest piece of advice. If it's number 2 and you see a deeper pool right underneath that low contributing cylinder, you can rule out a leaking intake valve, because the suspect cylinder is compressing, but the waveform, the intake waveform, is coming down instead of pressurizing as it would on an intake leak, an intake valve leak. So never forget that suspect cylinder. And if you think about it, doesn't matter which engine you have, when you're outside that center of the compression stroke of the suspect cylinder, the intake stroke will always be 360 degrees. So if you are suspecting an issue with that cylinder, you would expect to see a weaker pull 360 degrees after the top dead center of the suspect cylinder, not directly underneath it.
Okay. Now, in some of that analysis, when you're looking at it on the scope, and certain scopes make it really easy. You can set up rulers and degrees and stuff. One thing that's been really helpful for me, and I've used this with my students too, when we're kind of looking at some of these waveforms, is a piston chart. There's so much going on. We can pretty easily process one cylinder's 4-stroke cycle. That's not too difficult to do, but let's have a V6 and you've got 5 other cylinders going through 4-stroke processes. That can get kind of muddy to try to visualize that in your brain. Which stroke is each other cylinder on at that exact moment. So we use a piston chart, and I know you've used them before. Can you explain what that is? What is a piston chart? How would we use that in identifying what's going on?
So the piston chart was something, it's just another tool really. And it's not a perfect tool, but it is extremely helpful. And it's not perfect in the sense that it will tell you exactly where each intake valve opens, closes, or each exhaust valve opens or closes. It gives you a rough estimate based on the 4-stroke cycle. It's just basically split into 4. And what I did to kind of get a better idea as to where exactly these valve events are happening according to the piston charts, I used it with an in-cylinder waveform. And that helped me tremendously in seeing exactly where these valve events are happening across multiple vehicles. So the piston chart makes it a whole lot easier in the sense that depending on which kind of pulse you're taking, whether it's an intake pulse or an exhaust pulse, that piston chart can make it a lot easier to visualize the exhaust pulse of every cylinder in your analysis, or the intake pulse of every cylinder in your analysis. And it also makes it a lot easier to identify the companion cylinders of the suspect cylinder, which is crucial in these type of diagnostics as well.
And you've got some videos utilizing a piston chart. Is that correct?
That's correct. I actually have a video dedicated to how to use a piston chart, and I try to go as in depth as I can. I probably miss some things I usually do.
I'll put a link in the show notes to that video in case anybody is, more interested, it wants to find out more about what that is and how it works. Because if I can't show you the chart, it probably doesn't make a whole lot of sense. But again, really helpful in understanding where each cylinder is in the four-stroke process at one given point. So I'll put a link to that video in case anybody wants to watch more. But really, really helpful tool that I've found. Do you have a source? Because I know you purchased this software. Do you have a certain website or person or someone you purchased the piston chart from?
Yes, Scott Shine developed a TDC2, I think it's called, and you can find those piston charts in the drivabilityguys.com. I believe it includes the THE, the drivabilityguys.com. And it doesn't include every single firing order. I've had like twice that it's just couldn't pull up a piston chart because it wasn't included. But that's very rare, and it's been an awesome tool so far. It's not let me down other than that, other than those two times.
Sweet. I'll see if I can find a link to that as well. All right, so we can use these things in the intake and look at the different intake pulls from a cranking engine. And now you mentioned that we got to block off the PCV to basically block off the crankcase. Now we can use these pulse sensors in the crankcase as well. Is that correct?
Yeah, if you decide to, if you have multiple sensors, you can use them simultaneously as well, which is something that Bernie Thompson, who's like the king of this stuff,
yeah,
he highly suggests doing this all in one shot so that you can just have one capture all in one shot and done deal, basically.
Okay. And so if we were in the crankcase and we were turning this over and we saw a big pressure spike, pretty much the only thing that can be is compression leaking past a piston somehow, right?
Yes, and well, that can go two ways. Well, three ways: bad rings, a hole in the piston, or cylinder wash.
Yeah,
or
and
actually a scored wall, so which would probably count as bad rings.
yeah, you could have damage on the wall. The washed cylinder, and again, I think you have video about this, is a really important thing to remember too. Just because we have low compression and just because we have blow by past the rings more than you want doesn't necessarily mean that that car needs an engine. We can have fuel that washes the oil down on the cylinder walls and causes low compression. So don't ever just rule out. A lot of times we get to the point, I remember this as a tech. Oh, we got a mechanical problem. Call the customer, see, do they want to put an engine in this before I do anything else? And that is one thing you just want to keep in mind. So definitely cylinder wash cause low compression and pressure in the crankcase.
Great points. I try to tell that to everybody as much as I can. You never know if an injector is overly generous or a spark is weak, and it's our job to find the root cause, which is funny because I just did a live video, and those who know Keith DeFazio from New Level Auto, he was telling me that the injector must be stuck open or something, so on that video. And I was telling him, well, if the customer approves, we can dig further, right? So everything is depending on how deep does the customer want to go. So
yeah, there's always a stopping point. Like, okay, I gotta talk to him and see how we're gonna proceed. I know the feeling of I just want to figure this out. I just want to keep going. I don't care if I get paid, but yeah, sometimes you gotta stop yourself and wait.
that's true.
That's just our nature, though. So me and Cody actually talked about using them in the cooling system to detect a potential head gasket leak. So if anybody's interested in that, check out the episode with Cody Gaddy, and we talked about how we can utilize pulse sensors in the cooling system. The one other area that I've actually played around a little bit with them is in the exhaust. Okay, so we're actually putting the pulse sensor in the tailpipe of the vehicle, and we're looking at pulsations coming out of the exhaust. Now, you mentioned you're doing most of these tests cranking. Is that correct?
Yes.
Okay.
Most of them.
And I've done some cranking, but I've also done, I saw this technique being performed. I don't want anybody to think I came up with this by any means, but I've also messed around with them running, and you can detect a cylinder misfire in the exhaust on a running engine with a pulse sensor. Have you done anything with that?
I've done them a handful of times, only because of how many variables there are when it comes to exhaust pulse testing during a running condition. You have different kinds of exhaust systems. You have a V engine going into one. Those are my favorite. But then you have engines that have, full on exhaust, and they have 4 outlets, 4 mufflers, and you can't block them all. So there's so many variables. It's probably working against me, but my preference is always to rule out an intake valve issue, a lower end issue, and a coolant leak issue, and deduce basically that it has to be the exhaust. And all that can be done at the front without having to ever go to the back. But I do want to share something later on showing where that has bit me in the back, and I've learned my lesson.
Okay. Well, actually, that's a pretty good transition. I was wondering if you had any case studies that sort of showed, the advantages of using these types of sensors. Why would somebody go through the trouble of getting a scope, a sensor, learning this stuff? What's it going to do for them? So do you have any vehicles you can share with us today?
I have one case study, and it kind of got me because it came in with certain symptoms, and it just ended up being something that I was not expecting. So if you like, I could go ahead and share that now.
Yeah, let's go for it.
All right, so this vehicle was a 2005 Ford F-150, and as always, start out with a pre-scan, and there was only one code. It was a P0352, a coil B, primary or secondary circuit, which is cylinder 2, and brought it in, and it felt like a light misfire. It was a dead misfire in the sense that it was consistent, but it wasn't totally dead that I can identify it by removing ignition, cylinder by cylinder. So it became a bit difficult to finally pinpoint whether it was truly misfiring. You could put your hand over the exhaust and it didn't feel too great, but going in order, I looked at the primary and the secondary and the current of the suspect cylinder, number 2. I didn't find anything wrong. Compared them to all of the other cylinders, literally, and they were all identical. I could not say that it was misfiring because of the waveform. So I moved on, and since I was chasing a circuit code, it was misfiring, but it wasn't a dead misfire, as I said. So I was checking for that. I went with the code and I checked the circuit and pin drag tested it between the PCM and the coil. And I also compared static voltages between the suspect cylinder and the other cylinders, and they matched. So all of the power feeds were ruled out, basically. And I also, just in case, put some stable in 22 on the pins between the coil and the PCM, put it back together, and obviously it made no change to the condition in which the car came in. And once again, I put my hand over the exhaust. It didn't feel too great. And at this point in my, career, you could say, I resort to exhaust pulse as last resort. That's my last resort. And exhaust pulse is absolutely last. So I went ahead and did a relative compression test just to make it a thing. If you watch any of my videos, I always say do a relative compression test first, right? Even though we have a circuit code here, what we're dealing with is a circuit code. A misfire is a misfire. So I went ahead and did a relative compression test along with an intake pulse waveform. I do have the waveform here. I'm looking at it, and I will put something together so that those who are listening can refer to it later. But looking at the waveform, you couldn't tell that there was something going on here. It was a cranking waveform, obviously. It was a relative compression test, and I could not pick out a mechanical issue. And the intake pulse, it did have a bit of a wavy nature to it, but not enough for me to be able to pick out and say that any certain thing was wrong. So it was a consistent misfire. I could not identify exactly which cylinder it was coming from because of how light it was. So look at the scan data, look at the mode 6, we have misfires everywhere. And, you know, Fords, most of the time, their cylinder identification, their power balance tests, they're not too great, I would say.
Yeah, take it with a grain of salt, definitely. It can help you, but it can lead you astray as well. I've been there for sure.
Oh, absolutely. So like I said, exhaust pulse is my last resort. So I wanted to at least identify which cylinder's misfiring before I go too far and just hone in on that one cylinder. I figured if I could figure out what's going on to that cylinder, we'll be all right. We'll fix this vehicle. So I attempted a crankshaft position sensor waveform along with the math channel in order to look at the crank speed and see where it drops off. It's a synced crankshaft position sensor waveform. Put the math channel on in frequency, and it was everywhere as well. I could not pinpoint which cylinder was misfiring.
So you're expecting to see if there's a misfire, that crank speed should drop at a certain point, and that'll show up in that frequency. Is that the idea behind that test?
That is correct.
But you didn't see that.
No. I saw everything but that. The screen, the waveform was going crazy. Needless to say, I was getting frustrated up at this point. So I gave in. I did an exhaust pulse. This particular setup was a V engine. It's a Y setup. It goes 2 pipes into one and out the back through 1 pipe. So I got real lucky with that one. I did a synced exhaust pulse and found 3 large pulses and 3 weak ones. And this was an 8-cylinder engine, which was very strange. And I can only attribute it to the way it's designed. Like I said, every exhaust system is different. You know, the distance between the outlet of the exhaust and each cylinder is different. The engine was hot. You know, there's all kinds of variables here. And there was no denying that there was something wrong here in this exhaust pulse. 3 giant pulses and 3 small pulses. I immediately said, there's a clogged cat here. And funnily enough, I've always experienced every single time that when there's a bad cat, it will drive the fuel trims rich. And I wish I had the scan data saved, but I kid you not, this was lean on both sides. It was the strangest thing I've ever seen. I never suspected a cat issue because it was going lean. And I was just thinking maybe that's just because of the random misfires. It goes lean, right? So this was a huge surprise to me. And to continue on with the waveform, with the diagnosis, I went in cylinder. I wanted to know exactly how much back pressure was on both sides and compare them. And not only that, I wanted to rule out any kind of timing issues, any kind of root cause with timing, you know, leading to a cat failure or something like that, just so that the client wouldn't, you know, spend the money on the cat and only end up with some kind of timing issues. So looking at the in-cylinder waveforms, which, like I said, I'll go ahead and prepare something for you guys. Maybe we could put in the show notes a link to the case study later.
Yeah, definitely.
The wide open throttle on the passenger side, it was about 4.5 of back pressure. So it was by a lot of people's standards, that's too much, but it's not nearly as bad as the driver's side. So the driver's side, I went wide open throttle, and we had about 35 psi of back
Yeah,
pressure.
that'll do it.
Absolutely. And of course, I overlaid both waveforms, all intake and exhaust valve up. Intake valve timing were dead on. So timing is perfect. I can, condemn the cat without having some kind of other mechanical issue as an issue. And that was it. That was where I learned that I should do more exhaust pulse waveforms.
That's awesome. I actually, I hadn't even thought about, identifying a restricted cat in that manner, but it makes sense the way that it presented itself. And I mentioned in the last episode too, the in-cylinder pressure tester, using that pressure transducer, being able to see when that piston comes up on its exhaust stroke, you're not only seeing in cylinder, but you're seeing what's downstream in the exhaust. And it's a great way to identify that restricted exhaust system. It's usually a cat, but that's the final nail in the coffin. The other way that I had used the pulse sensor in the exhaust was try to identify, and it sounded like this was where you were maybe originally headed, but trying to identify which cylinder is missing, based on that exhaust. And it kind of plays off of the old, dollar bill trick that's been around forever, where you take a piece of paper or a dollar bill, that's what it's named after. You hold it at the back, on the tailpipe, if it only has one. The dual exhaust setup changes things, but hold it on the back of the tailpipe, and if it sucks it back in and slaps against that tailpipe, we've got a misfire. You had a cylinder that didn't have combustion, and it's pulling that dollar bill back in. It makes a really distinct slapping noise. So with a pulse sensor, we're seeing the same thing. We're seeing that negative pressure that's pulling the dollar bill in towards the tailpipe, but now we can maybe pick it out and say, you belong to this cylinder. There's my misfiring cylinder. So is that always necessary? Probably not, but I've had a couple older vehicles, I'm talking like no computers, where I want to identify a miss, and that's kind of one of the methods I was sort of experimenting with to see how reliable that test method was. And for the most part, I think the less cylinders an engine has, the better chance you've got of making that call correctly. The more cylinders, the more tricky it gets.
Absolutely. I totally agree. And it's not my strongest, it's not a strong point for me, exhaust pulses, but after dealing with that, I really do need to get more into it. It's just the amount of variables that are presented, not only the exhaust systems, like the variance, like the variables with those, but also crank speed. If you have a misfire, that crank speed slows down a bit. How's that going to, what reaction will the exhaust pulse have there? Not only what's going on within the cylinder of the suspect cylinder, but also with the crank speed there. So to me, I feel like it's my comfort zone to stay away from the exhaust pulse. And it's, like I said, in this case, it definitely worked against me. And ironic as it is, as much as I rely on intake pulse waveforms, usually you can tell when there's a clogged cap, because if you notice on an intake pulse waveform, the high peaks are when the exhaust valves are closing. So when the exhaust valve closes and then the intake valve opens, a big sign that you have a back pressure is that back pressure is blowing right back into the intake manifold upon intake valve opening, which this car did not exhibit that at all.
Interesting. I suppose maybe just the particular valve timing of that engine maybe played a role in that. What's the valve overlap on that engine? Maybe that had something to do with it. And that's, again, some of the things where you watch Brandon's videos and he's talking about the valve overlap, when both valves are open, and how you're seeing intake, things that are happening in the intake and the exhaust, and like you're saying, things that are happening in the exhaust and the intake. It's crazy stuff. It's so cool. It's really cool to learn. It can be tough when you're on the spot, on the job, trying to figure this out, but that's why we spend the time trying to learn this. You play around with it, you experiment with it, and find videos like what you've got that can move you along that learning, change that learning curve a little bit for you with this stuff like this.
Definitely. And just to put it out there, I guess, I did show a video in which this is a perfect example of where a clogged cat can have the same effect as an advanced exhaust valve timing. They both build cylinder pressure and release that into the intake manifold, and causes different effects to each engine. In this particular case, it gave us a map high reading and a code for that. It was, I believe, if I'm not mistaken, it was a 2009 Honda Accord. I have a video on it. Anybody wants to check it out. And I was totally convinced that the cats were clogged. And I went in cylinder and found that timing was off, and it had the same exact effect as a clogged cat would have on that intake manifold. So it's something to consider.
Yeah, interesting. Well, awesome. Thank you for sharing those case studies and your experience with the sensors. I definitely appreciate, like I said, the assistance and explanation there.
No problem.
What I'd like to do now is give you just a moment here to share any recommendations that you have. Number one, if it's tool, training, diagnostic wise, do you have any specific thing that you'd like to recommend? And then also, and this can kind of be, in conjunction with, but do you have any specific recommendations for somebody who is just trying to get better? Maybe they're just starting out. I've had a lot of people reach out to me on the podcast that are just getting going and they don't really know what direction to turn, but maybe it's just somebody that wants to improve their skills. They don't want to be hanging parts all day, every day. So I'll just let you go ahead and share any recommendations that you have.
Thanks. I appreciate that. I make it my duty to share as much as I can on YouTube, but I'd be lying if I said that YouTube was not totally instrumental in my learning. So if I could give any kind of resource, it would be a lot of YouTube channels. Obviously Scanner Danner goes without saying. New Level Auto, Diagnose Dan. There's Dead on Diagnostics, teaches a lot of scope stuff. Advice for somebody who wants to improve is put your head in it, do it. If you want to get into scopes, buy a scope. I started out with a Mixig, and it was a powerful scope. And, one thing led to another, and I finally worked up to a Pico, but you got to make the money first, obviously, and then you can invest on nicer tools. And the Pico, for what it's worth, it's not just a nicer tool. It opens doors. There's so many things that some might take for granted now that they've experienced the Pico scope for so long a time. But coming from a scope like the Mixig and transitioning to a Pico, you get to see it's just ridiculous how many different things you could do with a Pico if you just do the research, look up the Pico libraries, look up Train by Text, just type in whatever waveform you're looking for. Like, that's what I used to do. If I didn't know what a current ramp was, I would Google it, I would YouTube it. And you do have to read between the lines. You do have to cut out the bad information, but that's what happens when you research. You get as much information as you can and just sort through the bad stuff. and a lot of the in-cylinder stuff can be found in automotive-test-solutions.com. Bernie Thompson has a pretty nice library as to what you can find in certain systems in cylinder. There's a certain amount of YouTube videos that I would recommend as a must watch. And my number one must watch is the one from TST Seminars, Dave DeCourcy's video. He did an incredible job, and I just share that as much as I can. Also, there's another TST seminar video on YouTube by Mac Vandenbrink. There's another one from John Anello. John Anello has some pretty good videos up there too. Jim Morton, I mean, it goes without saying.
Yeah.
I don't know if he's listening, but I hope he's doing all right. And if it's something outside of online resources, I would say, like I always said, I've always said this to everybody. If you're just starting out and you're working alongside well-experienced technicians, hold the flashlight. You're doing them a favor. You're holding the flashlight, just watch and learn. You know, if they do something wrong, you learn from that too, right? Print out those diagrams for them. What are you looking at? Do you want me to print something out for you? You want me to look up the service info for you? Learn those systems. By helping others, you can actually learn yourself. So I take that with me every single day. I feel that every time I share something, I learn myself. So be generous is what I would say.
Yeah, that's great advice. You know, for a younger person who's all they're getting is oil changes and tires. You know, that's how a lot of us started out in the field. How do you learn this stuff if you don't even get a chance? You don't even get a crack at it. And that's a great way to pick up on some of it. Is if you work with somebody who's cool with that, and like you said, helping is probably going to make that easier, but it's cool with you kind of hovering, standing over their shoulder. I know I was there. I remember watching the guy doing intake on a 3-1. Just like, wow, this is crazy. How does he know where all these parts go? How's he figuring all this out? But yeah, you learn just a ton of little things from each time that you're spending with somebody who has, you know, 10, 20 years under their belt. And yeah, some of those videos you mentioned, great stuff, you know, hours worth of content for free. If you're not making use of that, you know, you're just, obviously everybody's busy, but you're wasting a free resource.
Mm-hmm.
I mean, you could probably watch YouTube until your eyes bleed on stuff, but there's some really good free content. That's the kind of the point here. So I will try to include everything we've mentioned in the show notes for anybody. Check those out. We'll have links to everything, so it'll be easy to find. Yeah, spend some time. I mean, what else are you going to do? Where are you going to go right now? Stuff's opening back up, I guess, but
yeah, I mean, take advantage, because now is the most time that we've ever had. And although YouTube is convenient, you have to seize the moment. You have to take advantage and take the time while you can to watch and learn. There was Scanner Danner that was responsible for me mustering the courage and the curiosity to buy a scope. And it was that Dave DeCourcy's video that I must have watched between 5 and 10 times back to back that is responsible for me buying an in-cylinder transducer. Started out with a PV350 by Fluke.
Okay.
And those of you who don't know, there's the scope-friendly one and the non-scope-friendly one. If it has a little blue box in it, those are the good ones. So it doesn't matter where it's made. USA, Mexico, if it has the little blue box, you're good to go.
Good to know. Awesome. Well, hey, I just want to thank you so much for coming on and chatting with me this evening. It's been awesome. We'll have to do this again sometime soon.
Oh, I would love to. That would be awesome, man. I appreciate you doing this, and I'm pretty surprised that we could do stuff like this nowadays. It's something that you couldn't do this 13 years ago.
No, I mean, when I started in the field, yeah, there's no YouTube. There's none of that. I think ITN was the only thing that I
No,
remember being
yeah,
around. That was it. And I mean, maybe it's a good thing that YouTube, wasn't around. Maybe you learn the hard way, but man, it would have been nice to have. The technology is awesome for sure.
absolutely. I I'm a big cheerleader for YouTube and stuff like that. Obviously, as a YouTuber, but even before becoming a YouTuber, I was always a huge fan of learning things through there. It has made it impossible for someone to pick up on whatever they need to do, you know.
I
And
I had to pull a tree out of my yard, and I had no idea how to do this. I'd never pulled a tree out of the ground before. Hey, YouTube, show me how to do this, and we
yeah,
figured out with a chain and an old rim and all that stuff. And it's it's a great resource for sure. But thanks again, and hopefully we'll be talking to you again soon.
yeah, I appreciate you, man. Looking forward for the next one, bud, and for the next episodes that are to follow as well, too.
All right. One last big thank you to Mario for being on the show today. Really appreciate it. And thank you to everyone that is listening. I appreciate you tuning in. Make sure to check out the show notes if you have not already, to check out some of the links referencing the case study, websites, including Mario's YouTube channel. Take some time, watch some videos there. He's got some really great stuff. Again, that's Super Mario Diagnostics on YouTube. And one last thing, if you are enjoying this podcast, you're liking the information, you're getting something out of it, if you could just do me a favor, hop onto whatever podcast service that you are using to listen to this podcast and just throw the show a rating and or review. That would be really helpful. It helps other people find this podcast and hopefully be able to reach more people and just share the knowledge. That's the whole goal here. But thanks again for listening. Have a great day. Let's get out there and start fixing the world one car at a time.